Hello, this is Mr. Stewart working on now the 2.3 quiz. At first, when I made these videos, I emphasized a lot of using a calculator, specifically using our scientific calculators that we use in the classroom, the Texas Instrument 30XS. These are the calculators we use. And they're nice calculators. They're great calculators, in fact. They have fraction buttons on them. And we use them in our classroom all the time, but the problem is students go home and take the quizzes and they don't have those same buttons on their same calculators. Most students only have like a basic 9-digit calculator, something that that would come with a computer or just your cell phones. And even if you do have a nice scientific calculator, most of those don't have the fraction buttons on them. And so what we're going to try to do today is talk to you about how you can approach these quizzes and how you're supposed to understand fractions rather than just compute fractions. So we're taking a different approach on this, and we want to make sure you understand that. Okay. So I'm going to show you how I would approach the math using just a simple 9-digit calculator. So let's start on the 2.3 quiz. Okay. All right. So if you take a look, it says subtract, write the fraction in simplest form. And I know 2.2 and 2.3, they're going to appear to be very similar. In fact, there's really no difference between 2.2 and 2.3 because, as you understand it, every subtraction, for example, when we worked with chapter 1, we would do something like this. Like every subtraction problem can be turned into an addition problem. For example, when you're working with the opposite of the opposite of a -3 happens to be a +3. So this is kind of how we're dealing with this here. And if you look at the fractions, these happen to be really nice fractions. Just don't forget what happens when you have this is the opposite of 1/4, and what is the opposite of a -1/4? And hopefully you remember this is actually going to be a +1/4. So we can convert this to something that looks like this. Now, at this point, after spending almost an entire week in my class solving fractions, if this is still a struggle for you, you need to come talk to me. We need to figure this out. Okay? You need to know what we're dealing with here. So here's an example. We're working with 3/4. Okay. So as you're looking at fractions, we're working with 3/4. That's 1/4. That's 2/4. That's 3/4. We're working with 3/4, and now we've decided we're taking away a -1/4, and taking away a -1/4 just happened to be plus 1/4. So we're adding to this 1/4. And so this is the idea of fractions, right? You're looking at 3/4 plus 1/4. Okay. So again, if this is something that you're struggling with, even looking at these and thinking, okay, what if I added this to this? Okay. If this is something you're struggling with, then we need to figure something out. We're going to keep going. Okay. With the decimals happen to be really nice. This is, maybe something. This is maybe when I'd use a calculator. I like calculators. I really do. I think they solve a lot of. They solve the time issue. It takes a lot of time sometimes to do things by hand, but what you need to know is sometimes these 9-digit calculators don't have a negative button. Maybe they just call this a subtract button, and so sometimes these 9-digit calculators won't be able to handle a negative number. But if you look at this carefully, again, here's the opposite of 2 and 97/100ths. And then you've got another negative out here, so this is similar to what happened last time. We're going to be working with a negative 7.99, and the opposite of 2.97 is a positive 2.97. Now, when you think about this on the number line, if this is something you're still struggling with, make sure you understand that each term is reflecting a direction on a number line, and that's it. So for example, this is a negative 7.99 going in this direction. That's a negative, so this is taking you in the negative direction. And once I look at this number, the positive 2.97, this is going to take me in the positive direction, but it's only going to take me 2 and 97/100ths in the positive direction, which is not as far as the negative 7 and 99/100ths took me. So as I'm looking at this, I know that first of all, it's almost like I'm subtracting. I'm finding the difference between these two. Okay, I'm finding the distance, right, from here to here. I'm finding the difference. And so this is subtraction, and I know the answer is going to be negative. Okay, so this is something that again your 9-digit calculator will be able to handle, but you might need to think of it as saying, okay, I just need to find the difference between these two, and just remember that in the end, the answer is going to be a negative. Okay, so this is, again, you don't need a fancy calculator to be able to do something like this. Alright, moving on. Okay, here's the next one, and just going to do a quick reminder that a negative, let's say a negative 9 and a negative 8, right here. Okay. Remember, we look at each one of these as terms, so this is from chapter 1. This is a term, and this is a term. If we identify each number as a term, then technically we can add any single expression we want together. Watch what happens. This is a term, it's a negative 9. This is a term, this is a negative 8. And now we can add these together. Right? So in other words, a negative 9 subtract 8 is going to be the same as a negative 9 plus a negative 8. It's the same thing. And I know what this is. This is going to be negative 17. This is also negative 17. And you can check with your calculator if you want to, but that's how it works. So if you come over here, you just need to remember this is a term. It's a negative 9 1/2. And the other one is also a term. It is a negative. It is a negative 8 3/10. And all I'm doing is taking two negative numbers and adding them together. I'm going in the negative direction, and I'm going in the negative direction again. So without even thinking about it, I mean, technically, do you have to solve this question? Possibly not if you're thinking about this logically. But I can show you. How you'd approach this. Let's make up a question real fast. Let's just do like a negative 2 1/2, and then a negative 3 and I don't know, 1. Let's do 1/5. Okay. And as you're looking at this, if I were going to add these, if I actually wanted to find the sum of these two numbers, the sum of these two negative numbers, what I would do is I would convert each one to an improper. It's going to be easier that way for me. So 2 times 2 is 4, plus 1 is 5. Got 5 halves here, and it's a negative still. Don't forget, it's still just a negative. And then I'm going to add that to the next number, which is, so 3 times 5 is 15, plus 1 is 16, so this is going to be a negative 16 fifths. Okay. No, I'm sorry, 15. Yeah, that's right, 16 fifths. So, the negative still comes down. I'm going to add these together, and I got to find a common denominator. This may not be necessary. I know some of you might be rolling your eyes thinking I don't need to do this, but this is something that I just like to show you so you feel comfortable. I'm going to find a number that they both go into evenly, and the first number I can think of is 10. 10 is going to be their common denominator, meaning 2 can go into 10 and 5 can go into 10 evenly. 2 times 5 is equal to 10. Whatever I do to the bottom, I have to do to the top, or I should say, whatever I do to the denominator, I have to do to the numerator to keep the fractions equivalent. I'm just going to abbreviate because I don't know how to spell it. And so 5 times 5 is 25, and don't forget, it's still a negative. And then looking at the next one here, okay, what did I have to do to 5 to get to 10? I have to multiply by 2, which means I have to do the same thing to the numerator. Whatever I do to the denominator, I have to do to the numerator in order to keep it equivalent. Now, this just becomes, 16 times 2, that's going to be 32. Again, this is my made-up one. Don't forget, it's still a negative. And don't forget, we are still just adding them together. Now, I've got 25 tenths, and they're negative, and I've got a negative 32 tenths. As you're looking at this is going to be, the denominator is going to be 10. The answer is definitely going to be negative, and this is why. Because we have a negative 25 plus a negative 32 in the numerator. And as we simplify this, I'm kind of running out of room there. That's going to be 5, 6, 7, and 3, 4, 5, a negative 52 tenths. This is my answer. And don't forget, it's probably going to want you to put it in mixed. And so I would think to myself, okay, how many times can 10 go into 57? How many times can 10 go into 57? And I think that's going to be 5 times. Don't forget, it's still just a negative. The negative just kind of tags along. And I'm left with, that would take me to 50. I'm left with 7 over 10. The denominator stays the same, and this is the leftover after I do, if I do 50 tenths. So, kind of, I know it looks messy. Fractions can get a little lengthy. Calculators do save time, but logical thinking saves even more time. So please use your logical skills on this one. Okay, not too bad of a question. I think pretty simple, pretty straightforward. Got yourself a positive. Then we've got ourselves a negative. Then we've got ourselves the opposite of a negative, which hopefully you remember is just a positive. So if I were to rewrite this, I would say this is a positive 3/8. I'm sorry, positive 3 8/10. Plus a negative, a negative 8 6/10. And then plus 4 2/10. Don't forget what happens when that double negative. Okay, and that's the really one thing. And well, you can rearrange the terms any way you want. Those are two positives, so it might be easier to add those up first. 4, 5, 6, 7, 8. So this actually combines together to make a positive 8, I believe. And now you're just adding that to a negative 8 6/10. So the 8s are probably going to be canceling out, and just think about what you're going to be getting here. And the last question seems lengthy. Let's see if we can kind of do some things with this. When you're working with 3 different fractions, in order to combine them all, you need them all to have the same denominator, but I would work with pairs. Maybe just see, first of all, if I can simplify anything, or if there's any way I can reduce anything. And a lot of times, just looking at your answers, multiple choices, you can almost cheat sometimes in a way. Most of you could probably solve this without even having to solve it, or find the answer without even having to solve it, just kind of using your skills, kind of thinking it should this be positive or negative. But, you know, I'm not going to solve this, but I'm going to tell you, if you're going to do this by hand, don't forget you've got a double negative here. So this is actually going to be 3 1/4 plus 25/6. And then you're going to be left with a plus a negative 8 4/5. And that'll kind of push you along a little bit more. My approach to solving fractions, if I can't clearly see a quick and easy solution, is to convert all of the mixed to improper. So 4 times 3 is 12, plus 1 is 13, so this is looking at 13/4 here. Plus 25/6, that's improper already, so I can just use that. And then 5 times 8 is 40, plus 4 is 44, so I'm going to add a negative 44/5 to that. Now comparing fractions, let's see. You know, the negative is going to be larger than the other two as far as farther from 0. But when you combine these two, let's see. You could probably think of, yeah, let's do this. I think I want to just show you how I would approach this. If I was just solving this by hand and not really thinking about it, I would probably just do it this way. I need to find a common denominator between 6 and 4. And the first one I think of is 12. So 12 and 12. And let's see, what did I have to do to 4 to get to 12? I have to multiply by 3, which means I'm going to do the same thing to the top. So this is 12, and so, you know, if you don't have your 13s times tables memorized, which most people don't, you could go to 12, and we know 3 times 12 is 36. 3 times 12 is 36, plus another 3 is 39. So there's 39. We're adding that to what I have to do here, multiply by 2, multiply by 2. And so 25 times 2 is 50. And, you know, I know this is looking a little messy, which again is one reason why calculators are very nice. But we need students to know how to do this stuff as well. So now we've got 39 twelfths and 50 twelfths, and we can add that together. So that's going to be 60, 70, 80, 89 twelfths, which seems like a crazy big number, but it's not really that big of a number. It's going to be, let's see, how many times does 12 go into 89? And this is where we get to use a calculator. Okay, so I just used my calculator, and it's saying this is going into it 7 times with a little bit left over. So it's going to be 7 and some 12, a couple of 12s. And in fact, 79, let's see, 77, 40, 84, 5, 6, 7, 8, 9. So it would be 7 and 5 twelfths, which isn't a big deal. 7 and 5 twelfths. That's totally manageable. Now, all we have to do is add a negative 44/5 to this. Now, I'm not going to solve this for you. I'm not going to keep going. I'm going to stop here and say, look, use the same patterns, find a common denominator, and use your calculator for stuff like this, right? For converting equivalent fractions. Use your 9-digit calculator for stuff like that. If your calculator doesn't have a fraction button, it's okay. You're still more than capable of doing this. So we're not sending you home, setting you up to fail, just training you how to do it on a calculator. We're teaching you this stuff in class as well, and it's very important that you do that. But anyway, hopefully this is helpful for you, and I hope you enjoyed. Have a good day.